Okay, so as I said, the channel of communication is MS Teams, Moodle, and the course website. Keep looking at the course website all the time for any important announcement. Okay. Moodle is important because that is where your quizzes will be held. Okay. Automatically graded after you have submitted your answers and so on. And MS Teams is where again communication will happen. Also, assignments, projects, any kind of announcements will be given there. So this website is very important. You should go to the website where there are references. The first reference is a book written by me and my ex-PhD student Aditya Joshi, who is now a faculty member in University of New South Wales in Australia. So that book is Natural Language Processing, where we take the view that any natural language processing task, like building a chatbot or a sentiment analyzer or a machine translation system, all these have gone through three different stages. Okay, the first stage was rule-based, where human beings sat down and gave rules for solving that task. For example, you give the rule that in French, the adjective goes after the noun. Okay, the blue palace will become palace blue. So there is a rule. But the next stage was statistical machine learning or statistical NLP, where feature engineering was done by human beings. And that gave some amount of success, many times a lot more success than the rule-based systems. In particular, statistical systems are much more robust. Okay, so the data sort of contained the underlying rules, and that became operative. But when deep learning came, that changed the picture drastically. Okay, and that of course required huge amount of data, and you do not require any rule there. In French, the adjective goes after the noun. There is no rule. Okay, data tells you that this will happen. Why? Why does it happen? It again happens by the force of probability, by the force of maximum likelihood. Okay, while you generate the target language sentence, okay, Ram chawal khata hai, the verb goes to the end because of the force of probability. How? When the natural language sentence is getting generated, a decoding process kicks in. In decoding, at every stage, you find out the most probable word or phrase at that location. Therefore, by the force of probability, the verb goes to the end in the Hindi sentence. In this course, I really require you, I insist and require you to have deep insight into probability and language phenomena. The verb going to the end in a Hindi sentence or adjective coming after the noun in a French sentence is a language phenomenon. How probability implements that phenomenon is the heart of the course. Okay, and that is very different from the way the course is taught at many other places in the country and in the world. Okay, this is a very unique feature of the course that I teach. Okay, you need deep insight into linguistics, language phenomena, and see how interestingly probability begins to shape those phenomena and give them an implementation. This is a very unique feature of the way I teach it. Okay, and you should get that hang of probability and language interacting with each other. Then you will really enjoy the course. And later in life, if you want to become a natural language processing researcher and devote your life to NLP, this is what will give you energy. This interaction between language and probability. Anyway, so now, as I was saying, the nitty-gritties, each quiz of 15% weightage, not Thursday, Friday, just before midsem and endsem, no midsem, no endsem, 4 assignments of 40% weightage. So you will have your assignment evaluation end of August, end of September, October, and one more before the end sem. All the 4 assignments will be graded and 40% weightage. Then there is a substantial course project where we want you to be creative and innovative. So the ask is high. You have to be ambitious in this course, and you can base your work on one single paper, which is the heart of your work, but build around it, and we would like to see something new brought in when you implement your project, even if it is based on one paper. Okay, so that creativity or innovation is very important. Remember that this will require heavy programming. Okay, I anticipate maybe you will write some 2,000, 3,000 lines of code, but more than that, understand lots of libraries, download things, tools, software, all those things. Okay, so those of you who are not programming savvy, do not enjoy programming, do not like coding much, I would request that you don't do this course. Okay, so so do not take it negatively. You'll not be comfortable doing this course with all other responsibilities and work that you have on hand. Okay, you will have to devote a considerable amount of time on coding and programming. So that's an important announcement I'd like to make right in the beginning, so that you know the reality. And your grade will heavily depend on the assignments. Assignments will be challenging. They will not be simple. Course project, of course, is demanding because we want some research output from it. And then the quizzes, of course, are there. So programming heavy. So to ensure that you are programming savvy, you are comfortable coding, next Tuesday, there will be a programming test for all of you for about 45 minutes or half an hour. I'll take half the lecture and then half an hour of coding programming test. There you must get 50% marks. Otherwise, I would want you to deregister. Okay. So this is something I would like you to do next week. Okay, is it clear? Yeah. Python. Yeah. Python. And so there you should do well. So this is a requirement for the course. You have to enjoy programming, and you'll have to do quite a lot of programming. Then for assignments, we'll have continuous evaluation. So every month at the end, there is an assignment evaluation. You will have to meet the assigned TAs every 2 weeks, and they will monitor your progress. So there should be several groups in the class doing course projects, and we have a big team of TAs also, so they will be able to give a lot of personal attention. I will decide based on the actual number of people in the class, the group size. 2 to 3 is the group size. 2 is absolutely ideal, but let's see how many are really doing the course, crediting the course. Can I just have a ballpark figure? All those who are planning to credit the course and do it seriously, raise your hand. Quite a few. And yeah, and those of you who want to do it seriously, raise your hand. Not so many. Okay. Right. So for your and there will be weightage given to literature survey, how thoroughly you have looked at the papers for your research project, and for that you will have to look at the journal. And in natural language processing, the most important journal is this MIT Press journal, Computational Linguistics, and there are a few others which have been listed. But more than journals, the conferences have been much more in attention of researchers because they publish absolutely cutting edge results. So ACL is again the epitome of the conferences, Association of Computational Linguistics. EMNLP is empirical methods in natural language processing. NACL is North American ACL, and so on. And of course, uh, for, very fundamental machine learning conferences like ICML, NeurIPS are also important for us because they quite frequently choose language processing problems and apply machine learning. And the computational linguistics community, on the other hand, would like to borrow techniques from machine learning. Then you will need to make use of many NLP, machine learning, and deep learning libraries, tools. NLTK is very useful. So you in the Python environment, in VS Code, if you're using VS Code, then in the Python program, you can import NLTK or you can import SPACY, which automatically give you a number of libraries and tools for solving useful problems. So importing NLTK, importing SPACY are crucial for many Python NLP programs. Make sure you look at what is NLTK and what is SPACY today itself. They will be your bread and butter going forward in the course all the time. Then PyTorch, TensorFlow, these are deep learning platforms. Hugging Face is an extremely important platform. They have benefited the researchers to no end, giving data, giving tools, making them open completely. Very useful. And Stanford Core NLP is mainly for classical NLP. Okay, so now to give you a flavor of what kind of things go on in our NLP activities in the institute, especially in our lab C field. Let me give you a glimpse of the research. And the hope is that once you look at this part of the presentation, you get to know what is expected of you and what kind of standard you will have to raise yourself to, okay, for doing good work. So let me repeat this. You will get a good grade in this course if you have shown your creativity, innovation in the project and have done your assignments meticulously, completely and correctly, covering all the phenomena which are involved. Okay. So for part of speech tagging, for example, you will not leave out part of speech tagging of prepositions, for example. Okay. So this is what is expected. Now, this is a research landscape which has happened in our lab. And they're all done by our PhD students, your seniors who are master students, bachelor students. And they're all in topmost venues in the area, topmost conferences. So let me proceed. So these days I begin all my talk and lecture with a poem, which I wrote, by the way, not ChatGPT. Okay, I wrote it. So the poem is, scientists ask why. Engineers ask why not. Scientists wonder at what is. Engineers wonder what could be. How we could change the world. World couldn't do without either. Scientists study, engineers make, and ever the twain shall meet. So the main message from the poem is that we need good science and good engineering for any successful system. Okay, good modeling, good understanding of phenomenon, and good implementation all have to go together. If you just implement without understanding the phenomenon and the mathematics of modeling, then you are just doing blind work, okay, inconsequential blind work. If you're doing only science and modeling, then you're talking in the air. There is no implementation, there is no meat to the ideas, there is no body given to the thoughts. So both science and engineering, modeling and implementation are important. Remember this as I make this presentation, and also remember this throughout the course. Now, phenomenon and modeling, this was actually the path was shown by physics, okay, where physics studies natural phenomena and tries to model. Physicists become extremely happy when they're able to give a nice, crisp mathematical formula. For example, this phenomenon was observed for millennia. An increase in the speed of a fluid occurs simultaneously with a decrease in static pressure. When the speed of the fluid increases, the pressure decreases. Okay, and this phenomenon has been seen by lots of people over millennia. Then came Newton's mechanics, and it was adapted to fluids. And then came this Bernoulli's equation. V square by 2 plus gz plus p by rho is equal to constant, where v is velocity, z is height, p is pressure, and rho is density. So this very nicely and crisply captures the phenomenon of decrease in pressure with increase in the speed of fluid, which is a phenomenon. And it has umpteen number of applications, for example, the fluid meter, okay, study of how a vessel, okay, will be affected by the speed of current and so on. All this is captured by this nice equation. That was modeling and implementation and an equation-based modeling. Then we move to language. So human language has been a matter of great intrigue for human beings. Okay? The amount of things we can communicate through the medium of language is just stupendous and mind-boggling. Human beings are also extremely creative with communication. Now, George Yule, who is a cognitive scientist and psychologist, had this seminal book in 1998 where he gave 6 properties defining human language. The first property is the most intriguing. It's called displacement. If you think about it, you cannot but wonder at the phenomenon. We can talk about places and times without physically being present at that place at that time. I saw him yesterday at the market. When I'm speaking, I'm not in the market. And it is not yesterday. Similarly, for the sentence, I will see him tomorrow in the school. This is called displacement. This is a positive point about language, which makes imagination, creativity possible. The next property is somewhat negative. It is called arbitrariness. The name meaning binding is completely arbitrary. Water, W-A-T-E-R, is water, pani. Why Hindi calls it pani and English calls it water, nobody knows. Okay, you may try to theorize, but all those theories are, faulty. They are just conjectures. Not all words are of this kind, actually. There is a set of words called onomatopoeic words. These words mimic the semantics of the word. For example, hiss. The snake is hissing. Okay, the word hiss mirrors the underlying semantics, which is the sound of the snake. But it's a very, very minuscule percentage of the words. Productivity and creativity, you can potentially have infinite number of sentences in a language. Now, this is also very surprising. You have finite number of words. You can have very large number of words, but still they're finite. Maybe, 1 million at most tokens, words. And the grammar rules are also finite. maybe just about 100, 200 rules. So with this repository of finite number of grammar rules and finite number of language elements, language blocks, how can you create infinite number of sentences? Clearly, this becomes possible because of recursion. Okay, a structure calls itself. So those of you who know finite state machine and pumping lemma would relate to it. Okay, finite number of states can produce or accept infinite number of strings only through pumping. Okay, there has to be a cycle in the finite state machine. So recursion is at the heart, and grammarians have captured recursion very well. Recursion has come to computer science with great benefit, especially programming languages. Cultural transmission, the child acquires the parent's language. This is again intriguing. Discreteness, sound and meaning units are separate. The words are separate from each other, but the meaning is a continuous spectrum. Okay, and duality is the difference between surface structure and deep structure. This happens in sarcasm metaphor, for example, where the surface meaning is different from the underlying deeper meaning. So these are 6 cardinal properties of human language. Then language phenomena are the different ways language operates. For example, there is this property called sandhi, where phonetic and phonological transformation happen at the word boundaries. Okay, so for example, guru plus adesh, two Sanskrit words, produce the word gurvadesh. So that's a sandhi rule. Some people say that none is also because of sandhi. No one. Okay, no one came to the class. None came to the class. Fronting of verbs is used in German to form questions. So move the verbs from the central position to the beginning, it becomes a question. Trinkst du Tee, do you drink tea? And semantic pragmatic incongruity. Incongruity is the phenomenon of inconsistency. So that leads to sarcasm, for example. And recently we published a paper which is opposite of sarcasm. It's called humble bragging. I have a small part in this presentation on humble bragging. So in sarcasm, if I say I love being ignored, it is a sarcastic statement. Nobody likes to be ignored. So if you say I love being ignored, that's a sarcastic statement. So that was a very, very brief intro to what is language phenomenon. But language phenomenon is extremely large field. Perspective 2 is NLP. What is NLP? NLP consists of 2 things: NLU, natural language understanding, and natural language processing. Several decades after the first advent of an NLP task, which was in 1960s, America and Russia were engaged in Cold War, and English to Russian and Russian to English translation became an important defense activity. Okay, so that's when it is said NLP was born, and artificial intelligence also was born with that. So that was NLU, and for several decades, it was morphological processing, parsing, okay, semantic analysis, which were components of NLU that kept happening. And it got refined. Parsing has become an extremely sophisticated field. We'll look at parsing, we'll look at morphology, all from the point of view of deep learning based implementations. These days, we find NLG definitely scores over NLU in terms of importance. This is the age of generative AI. And we know that large language models are producing excellent text, excellent image, okay, through the mechanism of generative AI. So it is imperative that you understand the mechanism of natural language generation, especially the nitty-gritties of decoding, how conditional probabilities are computed there, how decoding is done, how decoding is NP hard. Those things are very nice questions to look at. So generation 1 was rule-based, generation 2 was statistical machine learning-based, generation 3 is neural network-based, and I call LLM and generative AI as generation 3.5. In statistical NLP-based, in statistical NLP, we have seen some success stories. Hidden Markov model was very, very successful for part of speech tagging. Support vector machines were very good for document classification. Okay, all of which we'll touch upon and see their modeling and implementation in neural network. As I said, there are two pillars of NLP, linguistics and probability. But on top of these two pillars, you must place this particular structure, the coded NLP system. That is why coding is so important for NLP. Of course, you can generate a lot of code automatically these days through Copilot and ChatGPT and Comet now and so on. But coding ultimately is really the important final step. So what does linguistics bring in? How does it help? It helps annotating the data. The better the annotation, the better is the quality of training data, the better is the performance of a machine learning model. Another help that comes from linguistics is for error analysis after the results are produced by an NLP system. Suppose an NLP system which is built for sentiment analysis is consistently making mistakes for compound sentences, sentences which have and, or, but, etc., and it's making mistake there. So we apply our linguistic insight and try to get at the root of why this error is happening. Probability brings in two important concepts, the central limit theorem and law of large numbers. Law of large numbers is an intuitive law. It says that as you increase the amount of data, the probability values become more and more trustable. Okay, so this is law of large numbers, very intuitive. If you say that the probability of finding a noun in the data is 0.8, English language has the probability of finding a noun in the languages corpora as 0.8. So this value 80 by 100, okay, becomes more and more trustable as you increase the amount of data. Central limit theorem is intriguing. It says that any underlying distribution in the data can be approximated by normal distribution, okay, provided the amount of data crosses a threshold. And the moment you can model data through normal distribution, you are blessed with all the theorems, instruments, conceptual tools of normal distribution. Okay, that is the power of central limit theorem. These are not directly used in everyday implementation of NLP systems. But when they're in the background, remembering them again and again gives you a lot of insight and strength. Main challenge in NLP is ambiguity. So this is a very famous sentence. It is an artificial sentence. Nobody ever utters this sentence. But very famous sentence, buffalo, buffaloes, buffalo, buffaloes, buffalo, 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 buffaloes. Okay, buffalo, buffaloes, buffalo, buffaloes, buffalo, 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 buffaloes. I am sure none of you can understand the meaning of this sentence unless you have seen the answer before. Okay, maybe in my previous course that I taught, or maybe from your reading of literature and so on. So prompt to GPT is, what do you understand by the above sentence? ChatGPT's response is correct. It says Buffalo can be a noun, refers to the city of Buffalo. It says Buffalo can be a verb, means to bully, confuse, or baffle. Buffalo as a noun can also mean the animal, buffalo, bears. Okay. So now it says it describes a scenario where bison from buffalo are being intimidated or confused by other bison from the same place, who in turn are intimidating or confusing other bison. It's a playful sentence that plays on the multiple meanings of the word buffalo as a place. The answer is dot on. Oh, it's correct. So does it mean ChatGPT understands grammar language very well? No, it has just ingested it from some training data. Okay, somebody mentioned this sentence, gave the solution, and it went into the training data and it went into the memory of ChatGPT. Okay, so this is how the large language models acquire their power. Huge amount of context, huge amount of training data. So large number of patterns get integrated into the large language model. So NLP layers are also very well known. We'll navigate in these layers throughout the course. Morphology deals with breaking of words and their rejoining. Jaunga, for example, is ja and unga. So the activity of going and future tense. Part-of-speech tagging identifies nouns, verbs, adjectives, and so on. Chunking identifies small phrases, the blue sky. Parsing identifies bigger structures, the blue sky that was above me. Okay, that's a bigger, the blue sky that was above me was eventually overcast by cloud. So the blue sky that was above me is a parse structure, different from chunk. Chunks are very small phrases. And chunks should not have their own verb. Semantics deals with meaning, especially semantic role. Ram gave a book to Sham. Who is the giver? What was given? Who was the beneficiary? These things are in the purview of semantics. Discourse and co-reference deal with large pieces of text and especially are concerned with how the sentences are linked together to bring out a coherent meaning. One interesting thing you will observe, and this maybe some groups should take as a project, is what happens when large pieces of text are given for machine translation. You will see a very wonderful phenomenon. Each sentence may be completely correct with respect to translation. Each sentence individually is completely correct with respect to the translation. But as a body, the whole text is abysmally poor as far as translation is concerned. Okay, I don't know if you have seen bad quality translations of some tourist manuals and tourist documents. Each sentence is very nicely constructed, but as a whole, the document translation is not making any sense or very poorly translated. So one or two groups should work on discourse translation, okay, large document translation, and see what happens when the translation quality is investigated. Very nice problem. So here the sum is not, sorry, sum of individual entities is not equal to the whole. Okay, now it is surprising how there are so few tools for natural language processing in the context of deep learning. Okay, you will be either surprised or delighted or disappointed. Only some 3 or 4 tools, main tools. Yes. Softmax is a very important tool where a neural network can compute probability. It can give a vector which is a probability sequence. Cross entropy is the mechanism of comparing two probability vectors. And backpropagation by which the weights in a neural network are changed. So we'll spend some time in all of them, considerable amount of time on backpropagation. Just 3 very important tools. So you'll have to get a grip on all this. And then you are really very competent to take up large problems in NLP. Yeah, but don't think that after I have learned these 3 things, the deep learning for NLP course is over. There are a large number of fine nuances, fine ideas, and very exciting applications. Now, perspective 3 is language modeling. So language modeling is a form of modeling. So like modeling, it has to do prediction. All models do one thing, which is prediction. For example, you have seen this equation in your physics class, early physics class, is equal to ut plus half at squared. Given the initial velocity u, the time interval t, and the acceleration a, you can predict the distance the particle will cover. Similarly, given any three of these four entities, S, U, T, and A, you can predict the fourth one. That's what models do. Now, what do language models do? Is the name appropriate? Yes. Language models also do prediction. They predict the next language object. If you ask ChatGPT what is the capital of India, the answer comes out as Delhi. We know that ChatGPT has no understanding of the Constitution of India, what is the capital, and so on. Delhi just happens to be the highest conditional probability word at that position, given this context. Okay. Similarly, when you are summarizing a large piece of text, here we are saying something about Delhi. Delhi is a large, populous, and busy city. At every position, the word is the highest probability entity. Okay, so it is all a play of probability, and the prediction is happening through computation of probability, just like any other model. Only difference is that we do not have a nice, crisp, well-formed, and closed equation. Okay? So therefore, we have to make use of universal function approximation method, which are multi-layer neural networks. Okay, the multi-layer neural network contains the model of the phenomenon required for prediction. So language model also do one more thing. They predict the properties of language objects. For example, the movie was wonderful. The sentiment is predicted to be positive. The two words positive and sentiment come by language model. The two words are the highest probability words at that position. So large language models also predict, but they predict based on very long context. And we do find that creating large language models is an expensive proposition. It is of interest to see that the expenditure on Olympus by Amazon, okay, will be about $4 billion, which is more than the budget of Goa. Okay, that is a kind of expense. So these kind of small tidbits I'll keep giving you based on what we all read in Google News, Bing News, and so on. It is important to keep track of what is going on in the world with respect to deep neural network and the technology. Multilinguality is an important concern to deal with. India has these four families of language. The first family is Indo-Aryan group, where we see Bengali, Hindi, Marathi, Konkani, all these languages, the largest group. Then Dravidian languages, Tamil, Kannada, Telugu, and Malayalam. Of course, there is Kurgi also. Then this red border is the Tibeto-Burman languages, which are Manipuri, Bodo, such languages. And these few dots here, which are purple in color, they belong to Austroasiatic family, Khasi, Munda, and so on. What is the importance of multilinguality? The importance is transfer learning. We will learn the concept of transfer learning in machine learning course. And transfer learning is a big friend for NLP also. Languages which are close to each other. What does close to mean? Close to each other are languages which are typologically very similar. For example, Hindi is very similar to Gujarati and Punjabi, but not so similar to Tamil, which is far away. You can see in the language tree. And it is also not very similar to Bengali. There is typological distance. So we have seen in our experience that transfer learning is very helpful. If you can build an NLP system for Hindi, you can adapt it for Gujarati and Punjabi. There is a small part in my presentation on extremely low resource languages, part of speech tagging. Our PhD student Sanjeev has worked on that. And their transfer learning is at play. You have Hindi POS tag data and pretend as if the data is also for Angika, Maghi, which are from the Bihari group of languages. And it delivers. Even the zero shot setting, it gives reasonable accuracy. Okay, so NLP is a very nice test bed for transfer learning. Now I go to NLP of rare language phenomena. I don't know how much I can cover, but I definitely want to cover a few interesting pieces of work, recent pieces of work that we did. So we have been working on sarcasm, humor, metaphor, hyperbole for a long time, and have been getting series of high quality publications consistently. So sarcasm is a phenomenon, and the word comes from the Greek word sarkasmos, which means to tear flesh with teeth. Scary. Uh, the Sanskrit word corresponding to sarcasm is vakrokti, okay, a twisted utterance. So sarcasm essentially means an indirect twisted utterance which is meant to injure or hurt. Okay, so two things are there. Surface meaning is different from deep meaning, and sarcasm always hurts. So we started working on sarcasm, and we also understood that multimodality would be important for sarcasm. Okay, so look at this picture. This lady is saying, "Wow, well done," but it's not an appreciation. As human beings, you are very quickly able to spot that it is not appreciation. Because of what? Because of the eye, the body language, okay, the lip, and so on. And this text, passenger, thank you for sending me to Delhi and my luggage to Mumbai. Brilliant service. And the chatbot doesn't catch the sarcasm and says thank you for the appreciation. So how much more angry the person will become. So we investigated and saw that sarcasm really affects the accuracy of sentiment analyzer. Whenever a well-performing sentiment analyzer is subjected to sarcastic text, the accuracy falls drastically, almost to half. You can see on tweets, the accuracy falls from 49 to 20, 81 to 38. No, sorry, 50 to 17 and 69 to 35. Conversational transcripts, 49 to 20, 81 to about 40. Drastically falls. So we understood that sarcasm needs a different kind of investigation. And my student Aditya Joshi, his whole PhD was on sarcasm detection, and really did some pioneering work. Okay, um, uh, many of the sarcasm papers that you see cites our work on sarcasm very heavy. So I love being ignored. There is inconsistency here. Love and ignore. How can they both be together? 3 a.m. at work. Yeah is an expression of joy. And if somebody is working at 3 a.m., is the person really joyous? No, so that's an inconsistency. Up all night coughing, yummy, and so on. No power, yes, thank you, Storm. The phone has an awesome battery backup of 2 hours. All these are sarcastic sentences. If you look closely, it is inconsistency which is at the. So we computationally tried to capture explicit incongruity and implicit incongruity. Implicit incongruity is very difficult to catch. I love this research paper so much that I made a doggy bag out of it. Okay, so making a doggy bag out of research paper, that is not a good fate for the research paper. Sarcasm and sense ambiguity is an interesting interplay pointed to me by one of your seniors, maybe 2 years back. Oh, it is so nice of you to give me a ring early in the morning. If that ring means a gold ring, not sarcastic. But give me a ring early in the morning, waking me up, maybe sarcastic. Again, probability is at play. Maybe the person is happy because he or she was given a ring because he had to catch a bus or train. Okay, but sarcasm is possible here. Good to see you help dog bite victims. Do you see the sarcasm here? Because of structure. Good to see you help dog bite victims, victims which have been bitten by dog. Now, if you're helping a dog to bite a victim, that's strange and sarcastic. Right? Yeah. So language is beautiful, right? Language is beautiful. So this is how sarcasm is produced here because of syntax. Then we gave this mechanism based on very simple word embedding based representation and cosine similarity. And it attracted the attention of the community quite a lot. MIT Tech Review, then CSEM, all these are important fora for disseminating cutting edge technological advancement. They carried an article on our research on capturing of sarcasm through word embedding based measures. So if you have these feature sets like unigrams, capitalization, incongruity, explicit incongruity, these are normally used in sarcasm detection. So we use standard data sets, tweets, discussion forum posts, which are much nicer. And at that time, we achieved an accuracy which was better than the state of the art in all forms of data. So the heart of the matter was that we captured incongruity through word vectors and their cosine similarity. Look at this sentence. I did not create it. Okay? No offense meant to anybody. So this is from the actual corpus. A man needs a woman like a fish needs bicycle. Like is a preposition here, not a verb. That is the importance of part of speech tagging. This preposition has the property that the properties to its left should be similar to properties to its right. So on the right, if we see the cosine similarity between fish and bicycle, that's very low. Fish and bicycle are conceptually very, very far up. Man and women are conceptually close in terms of their conceptual content. So word vector similarity between man and woman is 0.766, between fish and bicycle 0.131. So this violates the requirement of like. There is inconsistency of dissimilarity of properties on both sides of like and therefore sarcasm. Okay, very simple measure, but we got good results as you can see here in the range of 80s, and that's why MIT Tech Review, CSEM, they carried articles on this work. Then we became a little more ambitious and we wanted to handle a very difficult form of sarcasm. That's called numerical sarcasm. And numerical sarcasm is where sarcasm arises from numbers. This phone has an awesome battery backup of 2 hours is sarcastic. Okay, because of the word awesome, and just 2 hours of battery backup is not really awesome. Okay, so that's why this sarcasm is arising from number. How to capture this? We gave some very simple rule-based system which produced about 80% accuracy, but a deep learning-based system gave us about 90% accuracy. So that was quite some time back based on CNN and feed-forward network. We got this system done. But now let me move to the phenomenon of humble bragging, where Sharath, my student, I think is your senior first, is just now presenting it in ACL in Vienna. Humble bragging is opposite of sarcasm. Inconsistency is involved there also. So look at this sentence, my life is miserable, I have to sign 500 autographs every day. Is the person's life really miserable? Maybe after a point of time. But initially, at least, the person must be bragging. So we wanted to capture humble bragging, and we saw that if we just simple-mindedly apply inconsistency, then sarcasm and humble bragging would be confused. Do you see that this is opposite of sarcasm? Okay. Here you are saying something negative, but actually the meaning is positive. My life is miserable, have to sign 500 autographs every day is humble bragging, not sarcasm. Okay, my life is wonderful. I have to labor hard to keep my family going. My life is wonderful. I have to labor hard to keep my family going. That's sarcastic. My life is miserable. Have to sign 500 autographs every day. Humble brag. Okay. At both places, there is inconsistency. Signing of 500 autographs is a lot of people will want to do that. Very positive. But miserable, the word miserable is negative. Okay. How do we have tackled this task? First of all, the problem statement. Given a piece of text, classify if the text is humble bragging or not. Can somebody tell the awards committee to chill, running out of my shelf space here? That is humble bragging. Oh, I love last minute changes. It is my favorite way to live. It's not humble bragging, it is sarcasm. So methodology is the following. What we do is that here large language models are heavily used and prompting is heavily used. So we tell the large language model through a prompt how to try to catch humble bragging. Our contribution here has been that the prompt is augmented with this four-tuple definition of humble brag, where B is the brag, BT is the brag type, M is the mask, and MT is the mask type. Can someone tell the awards committee to chill? This is the bragging part, and the type is achievement. Running out of shelf space here is the mask, okay? And the mask is, the type of the mask is complete. So is the text humble bragging or not? The answer should be yes or no. That is the problem statement. Now the foundation, I'll not spend a lot of time here. We, to our surprise and to our delight, we found quite a lot of work from psychology and cognitive science exists in humble bragging. Okay, that was a convenient situation for us. And let me tell you this, that NLP work, which is based on psychology, sociology, economics, physics, okay, is really a lot of excitement. Okay, try not to do only data processing. Try not to do only training of machine learning models and plotting graphs and placing numbers. Try to capture phenomena, try to have a lot of insight into what the machine learning model is doing. Two kinds of insight, insight into phenomena and insight into the model. Okay, so that's very different from simply churning a lot of numbers and taking one sophisticated machine learning model after another without any insight into what the model is doing. So computational humble bragging is a novel task and so on. Let me just skip this. It is very difficult to identify humble brag, that is true. In psychology, we do see a lot of work on humble bragging. Our contribution is that we have formed humble bragging as a binary classification. And we have given a four-tuple definition, which is our own. Okay. And we have contributed a new data set for both for benchmarking and also for training. And we have demonstrated the performance of humble bragging systems through different large language models. Okay, established benchmarks. So this is the four-tuple definition, as you have seen. And the data set required employing annotators who gave, in addition to yes, no, also whether the text is sarcastic, does it have bragging, does it have humble bragging, does it have complaint, is it neutral, and so on and so forth. So that is a time-consuming task. It requires a lot of people and a lot of manpower. So our results show that we achieve about 90% accuracy, F score of about 90 again. And the best result comes from zero shot on GPT 3.5. That is prompting only. plus the four tuple definition, which is added to the prompt. Okay, so that gives rise to that kind of accuracy. Baseline is quite poor, of course, just in the range of 30, 40, 50. Human performance is good, but surprisingly, for that data and for that benchmark, the LLM was better than human beings. Okay, and that does happen. We have seen that happen in a number of tasks. So we did analysis and we found that GPT-4o outperformed the humans. Then I think I'll have time only for rare language phenomena, low resource for later time. So we have been working on hyperbole and metaphor. Again, a very important problem. I'll show you why it is important. But the examples are the following. The principal is angry. It doesn't have hyperbole. There is no exaggeration there. And it also doesn't have metaphor. I will walk 1,000 miles to meet you. This is exaggeration. There is no metaphor in it. Life is a journey. There is no exaggeration, but it is metaphorical. Okay, life is being compared to a journey. The principal is going to cook us. That is both hyperbole and metaphor. So is this important? Is metaphor detection important? This is a contrived example, but it is happening. The chatbot asks, "How was your day?" Human being, okay, human interaction. "It was raining profits today." Maybe the person is a businessman. "Oh, remember to take an umbrella next time." Okay, the chatbot says. "I meant I made a ton of money." That must have been heavy. And then sighing. So difficult for chatbots to catch sarcasm, humble bragging, metaphor, hyperbole. These are not very frequently occurring phenomena, but they have to be tackled anyway. Okay. So the schematic is shown here, and I am not going to spend a lot of time here. We saw that if we use a multitask neural network, deep learning system, where the two tasks, hyperbole and metaphor, share parameters, the performance of each of them improves. This comes from a deep linguistic insight. Metaphor and hyperbole are related phenomena. Often one coexists with the other. Okay, so this we tried to capture, and we created data also. We augmented data, hypo-L, trophy, LCC. Wherever hyperbole was not marked, we marked. Wherever metaphor was not marked, we marked. And then we obtained results of this kind. Multitask learning gave us much better figure than single task learning for all the data items. Qualitatively also, we have seen that we are doing better. And we have established new SOTA, that means new state-of-the-art figures for hyperbole and metaphor. Okay, so our figures are currently the best. Of course, likely to fall again because of the advancement in the field. Qualitatively also, we have analyzed the results. Her strength awoke in poets and abiding love. So actually it is non-hyperbolic but metaphoric. The multitask learning gave non-hyperbolic and metaphoric. Single task learning gave hyperbolic and metaphoric. That was a mistake. So that was the rare language phenomena. I'll very quickly go over NLP of low resource settings very quickly, because from next week we'll begin the actual course content. And I have a few things to say here. So this was the work of Sanjeev. Sanjeev, you are here in the class. Yeah. He is also TA for your course. So part-of-speech tagging of extremely low resource languages. For all languages, we have to start with the part-of-speech tagging task. Very important fundamental task. So I'm not going into a lot of details. Sanjeev himself will take a lecture on part-of-speech tagging of extremely low resource languages. But I would like to draw your attention to some nice ideas. So first of all, there is hardly any data set for extremely low resource language. That's why they are called extremely low resource language. Hardly any data. And but fortunately, the languages that we dealt with had a lot of linguistic tradition. They are Angika, Maghi, and Bhojpuri, and they belong to what is called the Bihari group of languages. Hmm? Yeah, and they are also in the Indo-Aryan family. They are very similar to Hindi. Subject, object, verb construction. So this is the architecture, but let me go to some results. When you pretend as if the Hindi data is for Angika, Maghi, and Bhojpuri and do nothing, okay, just take this data and train a model, assuming you are training a Angika, POS Tagger, Maghi, POS Tagger, Bhojpuri, POS Tagger, you do get reasonable accuracy in the range of 70s, okay. 70 is F score. Doing nothing, just pretending Hindi data to be the training data for these languages. And there is this look back strategy, which is also nice, where you take the subwords of the language, their parts, their morphemes. And if you take Jaunga, and I'll give the Bengali Hindi example. Bengali is my mother tongue. So if if I'm considering what could be the part of speech of Jabo, will go. Because Jabo and Jaunga have the same root, Ja. And since Jaunga has verb part of speech tag, Jabo also must be verb. That is a simple idea. And in look back with score, you give different score to the morphemes and take the morpheme with the highest score. So these details will be brought out by Sanjeev as we move ahead. And through the subwording idea, you can see we achieve an accuracy or F score of about 0.8. Part of speech accuracy also has been investigated, and adjectives we do see have good accuracy in the range of 70s. Part of speech tag accuracy should be a concern in the course, okay? Because part of speech tagging is the first fundamental activity for NLP, and this kind of investigation of part of speech accuracy is important. So now I'd like to finish with a piece of work which and this is a collaboration between Hyundai and IIT Bombay. So here what happens is that Hyundai already has an in-car AI assistant. So that AI assistant helps the driver navigate the city, gives important information about sights and sounds, police station, medical hospitals, and so on. But it falters on multi-turn dialogues. When the conversation becomes longer, that AI agent begins to show its brittleness. Also, it is not multilingual. So our tasks are twofold: make it multilingual and make it long conversation savvy. Hmm? You will also see yourself when you interact with a chatbot for a long time. After some time, the chatbot begins to waver, begins to show its weakness as you go deeper. Okay. Now, what does going deeper mean? And how do you evaluate the depth of questions, qualitative questions? So there, we were very serious about it. And we wanted the data to have the 3 V's: volume, variability, and velocity. High amount of data, a lot of diverse data, and uh, data in uh, data coming fast and thick for training the model. So as I said, the follow-up questions is the main task of the AI agent, an automatic evaluation of these follow-up questions. So Bloom's taxonomy is a nice educational concept, very old educational concept, where we have 6 kinds of questions. Remember, easiest, understand, slightly more difficult, apply more difficult, analyze more difficult, evaluate difficult, create is the highest level of difficulty. 6 kind of questions. And as we make longer and longer conversation, we begin to move up this hierarchy. So what we see is that um, if I take this example, what is photosynthesis? That is a remember kind of question. In your own words, explain how plants use sunlight to make food. That requires understanding photosynthesis. Apply. Given a sealed jar with a water plant under sunlight, predict what would happen to the oxygen level in the jar over time. You are applying the knowledge of photosynthesis to answer this. Compare and contrast the roles of chlorophyll and stomata in the photosynthesis process. This is analysis. Plants perform photosynthesis only during the daytime. Support your judgment with evidence. That is evaluation. And design a simple experiment to test how different colors of light affect the rate of photosynthesis in spinach leaves. This is great. So we have corresponding situation in car AI interaction also. How do I make a call? Remember, what are the different options I have to make a call? Understand. It's a follow-up question. How does the call making process differ from my previous car model? Follow-up question to apply. What are the advantages of using the car's built-in calling system over my phone's calling feature? Follow-up question number 3. This requires analysis. Can you explain how the car's calling system integrates with my phone's contact list and how it affects call quality? This follow-up question 4, and it is of the type evaluation. How can I use the call making feature in this car to improve my safety while driving, such as by using voice commands or hands-free model? This follow-up question 5, and this requires creativity. So we invoked Bloom's hierarchy, or we rather modeled Bloom's hierarchy to generate follow-up questions in a systematic way. We also did one more thing. These evaluation of these follow-up questions requires huge amount of manual effort. We thought, why not ask LLMs to evaluate them, prompt them appropriately, and ask them to evaluate. How do you prompt? What is the guiding principle for prompting? We are guided by a very celebrated work in cognitive science called Grice's maxims. This paper was in ACL. This paper is in ACL industry this year. Okay, I think it's a good piece of work. So Grice's maxims are maximum quality, quantity, relation, and manner. Maximum quality ensures truthfulness and consistency. What is the current battery health status? Based on the last diagnostic report, has the battery health improved or declined? So, you can look at the slides to absorb things better later, but it's a good follow-up question. It satisfies maximum quality. Is the battery at 100%? If the battery is at 100%, why is it showing as completely dead? That's a bad follow-up question, according to maximum quality. Maximum quantity, you should give the exact amount of information, not more, not less. How do I use voice commands? Which voice commands help me navigate to nearby restaurants and control music playback? That's a good follow-up question according to maximum of quantity. Maximum of relation, what is the current tire pressure? What is the recommended tire pressure for highway driving? Relevant. Can you tell me the weather forecast for tomorrow? Not relevant for this question. Maximum of manner, how do I connect my phone to the car's Bluetooth? What is the quickest way to pair my phone with Bluetooth? That's a good follow-up question, depending on the maximum manner. So what we did was, based on these maxims, we came up with 4 formulae to evaluate whether the follow-up question is a good question or not. Good question means it must adhere to the Grice's 4 maxims. So we measured them by entailed relation, entropy, cosine similarity, and the structure of the dependency parts, which I'm not going to describe now. And the system made use of follow-up question generation through LLM and prompting. It also evaluated follow-up question through prompting based on Grice's maxims. Okay, so prompt template is shown here. Human beings have evaluated these. Our results show that the follow-up questions which are generated are best in Mistral, okay, according to human evaluation. And these analysis, let me skip. language and computation, you should remember it's a combination of language and computation, linguistics and probability throughout the course. Then rare language phenomena need to be tackled, otherwise you are not satisfying inclusivity. Languages which are in the fringes of NLP, what are you doing about them? And low resource setting is also very important. Okay, let me finish here, but important announcements. So every week, the Tuesday lecture will be taken by me, where I'll cover the foundations. And the Friday lecture will be taken by some guest speaker. The guest speakers are from IBM, Microsoft, then Google, Ministry of IT. Okay,